Good afternoon, everyone. I am Nirisha Sriramoju, one of the trainer in Sankhyanna Consultancy Services. Today, we are going to discuss about clinical domain models. So, what are the models? What are the general assumptions of domains as well as the variables, and each and every concept? We shall have a look, and let's discuss about today's agenda. So today we are going to discuss about general assumptions as well as how we can split the domains, that is about splitting domains we are going to see, and apart from that we are also going to see about the origin of your metadata, and later we also see about the variable assumptions, that is assumptions of your variables, how your variables are, what are the values to be included, and all those concepts. So let's see about your general assumptions first, that is your general domain assumptions. So here we can review your study data tabulation and implementation guide, that is before attempting to use any of your individual domain models, you can use or you can see the case report tabulation data definition specification, that is nothing but we call in general as define XML, and that is also available in your CDISC website, so you can go through about the define XML files, and how it is going to get represented, or the documentation part we can refer in as well as in your CDISC website. Later we have your relationship to analysis data sets. So for this, a specific guidance on how to prepare your analysis data sets can be found in your ADAM, that is nothing but your CDISC analysis data model, that is ADAM implementation guide, and any other ADAM documents you can find out about this general assumptions of domain. Apart from that, we have additional timing variables. These additional timing variables can be added as needed to a standard domain model based upon three general observation classes, except where discouraged in assumptions as well as in your specific domain assumptions. So these timing variables can be added to a special purpose domains only where specified in your SDTM IG domain model assumptions. So these timing variables cannot be added to your subqual data cells or to your RELREC. And coming to your order of the variables, so the order of the variables in the define.xml must reflect the order of variables in the dataset. So the order of variables in your CDIS domain models has been chosen to facilitate the review of the models and application of the models as well. So variables for the three general observation classes must be ordered with identifiers first, followed by your topic, qualifier, and timing variables. So first comes your identifiers, that is later on it can be your topic, qualifier, and the timing variables. Coming to your CD score variables, the concept of the score variable is used both as a measure of your compliance and to provide general guidance to the sponsors as well. So there are three categories of your variables which are specified in the core column of the domain models. One is required, the other is expected, and the last is your permissible variable. So based upon the core variables, coming to your required variables, there can be any variable that is basic to the identification of your data record, that is essential key variables and your topic variable as well. So it is necessary to make the record meaningful. So required variables must always be included in the data set and cannot be null for any record. So coming to your expected variable now, so it must always be necessary variable to make a record useful in the context of your specific domain. So expected variables may contain some null values, but in most cases will not contain null values for every record. So when no data has been collected for an expected variable, however, a null column must still be included in the data set, and a comment must be included in the define.xml to state that data was not collected. So make a note of that. when you have null values. Coming to your permissible variable should be used in a domain as appropriate when collected or derived. So, except where restricted by specific domain assumptions, any SDTM timing and identifier variables and any even qualifier variables from your same general observation class are permissible for use in the domain based upon that general observation class. So the sponsor can decide whether a permissible variable should be included as a column when all values for that variable are null. So the sponsor does not have the discretion to exclude permissible variables when they contain data. So even additional guidance is also there based upon your data set naming. So let's see that also. So your SDTM data sets are normally named to be consistent based upon the domain code. For example, demographics data set we can say as named as dm.xpt files. So in some cases sponsors may need to define new custom domains other than those represented in your SDTM-IG or found in the CDISC terminology, and may be concerned that series domain codes defined in the future will conflict with those they choose to use. So to eliminate any risk of a sponsor using a name that CDISC later determines to have a different meaning, so domain codes beginning with the letters X, Y or Z have been reserved for the creation of your custom domains. So any letter or number must be or may be used in the second position. Note the use of codes beginning with X, Y or Z is optional and not required for your custom domains as well. So now let's see about splitting the domains. So how the domains are split. So sponsors may choose to split a domain of topically related information into physically separate datasets. In such cases, one of the two approaches should be implemented. For a domain based on your general observation class, a splitting should be according to the values in category that which must not be null or based upon the findings about domain can be split either with your category values or relative to your parent domain of the value like in OBJ objectives. For example, FACM would store findings about concomitant medication records. So naming your findings about domains for more details you can also visit the website, and how to follow the rules must be adhered when splitting a domain into separate datasets to ensure they can be appended back into one domain dataset. That is, the value of domain must be consistent across the separate datasets as it would have been if they have not been split. So all variables that require a domain prefix like your test code location must be used in the value of domain as a prefix. So we also have sequence for all most of the domains like adverse events, LB, etc. So the sequence variables must be unique within your unique subject ID for all records across all the split datasets. So if there are 1000 records for your unique subject ID across separate datasets, all your 1000 records need unique values for sequence. So when relationship datasets relate back to split parent domains, your ID var should generally be the sequence. That is, when ID var is a value other than sequence, maybe like your group IDs, reference IDs, like that, care should be taken to ensure that the parent records across the split datasets have unique values for your variable specified in the ID var. So that related children records do not accidentally join back to incorrect parent records. So permissible variables included in one split dataset need not be included in all your split dataset. So it should be the datasets be appended in SAS. Permissible variables not used in some split datasets will have null values in the appended datasets. So care is advised, however, when considered your variable order. So split your dataset names can be up to 4 characters in length. Suppose for example if splitting based upon category, then your dataset names would be the domain name plus up to 2 additional characters you can split. So if we have like questionnaire is 36, so for splitting you can use like sf hyphen 36. So if this splitting findings about by parent domain, then the dataset name would be the domain name plus the 2 character domain code describing your parent code like FACM, findings about your concomitant medication. So the 4 character dataset name limitation allows the use of your supplemental qualifier dataset associated with your split dataset. Next, coming to your supplemental qualifier datasets for split domains would also be split. So the nomenclature would include the additional 1 or 2 characters used to identify your split dataset. Even your R domain in your subquels datasets would be the 2 character domain code. So in relation rec, if your dataset level relationship is defined for a split of findings about domain, then our domain may contain the 4 character dataset name. So now let's see about your metadata origin. So origin of your metadata based upon the variables. The origin column of your define.xml is used to indicate where the data originated. So its purpose is to unambiguously communicate to your reviewer whether data was collected on a CRF and thus should be traceable to an annotated CRF, or derived and thus traceable to some derivation algorithm, or assigned by some subjective process that's may be traceable to some external evaluator. And the CD SDTM-IJ defines the following control terms for specifying the origin, that other values may be defined or by other standards. So coming to your CRF, the designation of CRF as an origin is a define.xml, means that data was collected as a part of a CRF and that there is an annotated CRF associated with the variable. So sponsors may specify additional details about the origin that may be helpful to the reviewer. Example may include your electronic diary in your comment session of your define.example. So an origin of your CRF includes information that is pre-printed on the CRF. Say for example respiratory system disorders based upon your medical history category. And coming to EDT, that is the designation of EDT as an origin in the define.xml means that the data are received via an electronic data transfer and usually does not have associated annotations. So an origin of your electronic data transfer refers to data collected via data streams. It might be like your laboratory, ECG or IVRS. So sponsors may specify additional details about the origin that may be helpful to the reviewer in the comment section of your define.xml. Next we have your derived. So derived data are not directly collected on the CRF but are calculated by an algorithm or reproducible rule which is dependent upon other data values. So this algorithm is applied across all values and may reference other SDTM datasets. The derivation is assumed to be performed by the sponsor. So this does not apply to your derived lab results performed directly in the labs or by any other devices. Suppose distinctive collection between and derived values includes like a value derived by an eCRF system from other entered fields has an origin of derived. So since the sponsor controls the derivation, a value derived from collected data by the sponsor or a CRO working on their behalf had an origin of derived. So a value derived by an investigator and written or encountered any of the values of CRF has an origin of CRF itself, so rather than your derived. So a value derived by a vendor, say for example a central lab, according to their procedures is considered collected rather than derived, and would have an origin of your electronic data transfer. Yes, coming to your assigned. So a value that is determined by individual judgment by means of an evaluator other than your subject or investigator. So rather than collected as part of your CRF or derived based on an algorithm, this may include third party attributions by an adjudicator. So coded terms that are supplied as part of a coding process, maybe in your decode options, or the variable, are considered to have an origin of your assigned. So values that are set independently of any subject related data values in order to complete your SDTM fields such as domain and test code are considered to have your origin of assigned. Next we have protocol. So what is this? A value that is defined as a part of your trial design preparation, maybe in your trial design datasets. An example would be like your vital signs position, so which may be specified only in the protocol and not appear on a CRF. So the term sponsor defined was used in earlier versions of your SDTM IG to advise the sponsor to supply the appropriate origin value in the metadata. So the text sponsor defined was not intended to be used in your define.xml and is no longer used right now. So origin your metadata for records. So sponsors are cautioned to recognize that the origin of your derived means that all values for that variable were derived, and that CRF means all that were collected. So in some cases both collected and derived values may be reported in the same field. So for example, some records in findings datasets such as your questionnaires contains values collected from CRF, and other records may contain derived values such as your total score. So when both derived and collected values are reported in a field, the value level metadata origin will indicate at the test level if the value is derived or CRF, and the variable level metadata origin will list all types for the variable separated by commas like derived comma CRF. So how can you assign your natural keys in your metadata? Using your CD's domain models in regulatory submissions, dataset metadata indicates that a sponsor should include in the metadata the variables that contribute to your natural key for a domain. So in a case where a dataset includes a mix of records with different natural keys, the natural key that provides the most granularity is the one that should be provided. So for example, in a rheumatoid arthritis study where repetitive measurements of bone erosion in the hands and wrists might be made using both X-ray and your MRI equipment. So one approach to recording this data might be to create an individual test code value for each measurement. So just take the flanges. A sponsor might want to express the following in a test code in order to make it unique. So left or right hand phalange position, whether proximal, distal or middle, even the rotation of the hand, method of measurement, whether X-ray, MRI, and the machine model, trying to encapsulate all of this information within a unique value of your test code variable, which is not a recommended approach for some reasons. So it may result in creation of potentially large number of test codes, like your 8 character values of test code becoming less intuitively meaningful. So multiple test codes are essentially representing the same test or measurement simply to accommodate attributes of a test within your test code value itself. So these may include like your domains like location, method, etc. So now this domain includes both domain variables and supplemental qualifier variables that is going to control or contribute to your natural key for each row and to describe the uniqueness of your test. Now coming to your general variable assumptions, you have variable naming conventions where SDTM variables are named according to a set of conventions using fragment names. It might be variables with names ending in cd or short versions of associated variables that do not include the cd suffix. Examples can be your test code, which is the short version of your test, and the values of test code must be limited to only 8 characters and cannot start with a number, nor can they contain characters other than letters, numbers, or underscore. So this is to avoid possible incompatibility with your SAS transport files. So this limitation will be in effect until the use of other formats, might be your SDS XML formats, which becomes acceptable to your regulatory authorities as well. So you may have your QNAM, which serves the same purpose as test code within supplemental qualified datasets, and so the value based upon the subject, which are restrictions for the values of your test code. So the values of other CD or codes are not subject to the same restrictions like your test code. So you have like your element code, ET code, and TS param code. You have parameters code, that is nothing but your TS param, which are limited to 8 characters and do not have special character restrictions. So these values should be short for ease of use in programming, but it is not expected that they will need to serve as variable names. You even have your ARM code, which is limited to 20 characters and does not have special character restrictions. Even the maximum length of your ARM code is longer than for other short variables to accommodate the kind of values that are likely to be needed for your crossover trials as well. So for example, if your ARM code values for a 7 period crossover were constructed using 2 character abbreviations for each treatment and separating with hyphens, the length of your ARM code value should be 20. So this same rule applies to your actual ARM code as well. So variable descriptive names such as your labels up to 40 characters should be provided as your data variable labels. Now coming to your 2-character domain identifier, in order to minimize the risk of difficulty when you are going to merge or join domains for reporting purposes, the 2-character domain identifier is used as a prefix in most variable names like special purpose domains and your standard domains, trial design domains, your relationship datasets representing your relationships and datas which are already there to specify the complete variable name. So no action is required when creating custom domains based on your general observation classes. Sponsors must replace the 2 hyphens prefix in your general observation class timing and identify variables with your 2-character domain identifier variable, so that your domain or the dataset is going to get created. And the 2-character domain code is limited to A to Z for the first character, and I can say A to Z or 0 to 9 for your second character. So no special characters are allowed for compatibility with your SAS transport files. And whenever you are naming your file for electronic, that is ECTD, electronic common technical document, the philosophy which is applied to determine which variable names we are going to use as a prefix with your domain identifier in which they originate, except the following like your required identifiers like study ID, domain, unique subject ID. And also you need to ensure commonly used grouping and merge keys like your visit, visit number, visit day, and many of the variables in your trial design. It might be like your element and and next you have your demographics domain like your DM variables other than your DM, dates DTC, and your days DY, right? All the variables in your relationship records and subquents, and some variables in your comments and trial design datasets. So required identifiers are not prefixed because they are usually used as keys when merging or joining your observations. Now let's see about how to use your subject and unique subject ID. So subject should be used where applicable to generally refer to both patients and your healthy volunteers. So in order to be consistent with your recommendation in FDA guidance, your term subject should be used inconsistently in all labels and your define XML comments. So, to identify a subject unique across all studies for all applications or submissions involving your product, that is based upon your unique identifier, unique subject ID, should be assigned and included in all the datasets. The unique subject ID, which is required in all datasets containing your subject level data, it must be unique based upon your trial subject across all trials in the submission as well. So this is going to say that no two subjects across all the trials in the submission may have the same unique subject ID. So you need to ensure that about your subject ID, where no two subjects across trials in a submission must have the same unique subject ID. And coming to the case use of text in submitted data. So it is recommended that text data to be submitted in uppercase text only. Exceptions may include long text data such as your comments, values of your test in findings data set, so which may be more readable in title case if you use the labels in transposed views, and certain control terminologies as well that are already in mixed case. So the case used in your text data must match the case used in your control terminology provided in your define XML. Next you have the last convention of missing values or convention for your missing values. For individual data items should be represented by nulls. That is, this is a change from previous version of your SDTM-IG, which will allow sponsors to define their conventions for missing values. Even the conventions for representing your observations are not done using your SDTM. Either it can be your stat and reason where not defined variables are addressed. So test not done and the individual domain models. So based upon this, your grouping variables and characterization or categorization is also done. So grouping variables are identifiers and qualifiers that group your records in your SDTM domains or the datasets. It might be belonging to category or the subcategory variables assigned by sponsors to categorize your topic variable values. Maybe for example your lab record, you have lab test, its value is sodium. It might contain LB category, it that is based upon the chemistry lab, and the subcategory can be of electrolytes. So values based on category and subcategory should not be redundant with your domain name or dictionary classification provided by your decode and bodices variables as well. You have hierarchy of grouping variables, maybe representing your study ID, domain, category, subcategory, or else like unique subject ID, group ID, link of that group, everything. So how your grouping variables group your data based upon subject, across the subject and within the subjects. Coming to subjects, all records with the same unique subject ID values are a group of records that's going to describe about the subjects. Across the subjects means records with different unique subject IDs. All records with the same study ID value are a group of records that will describe your study. So all records within the same domain value are a group of records that describe about the domain. And next, coming to your category and subcategory values for the subset groups within the domain. Later generally you have category and subcategory values which have meaning within a particular domain. However, it is possible to use the same value for your category and subcategory in some of the related domains, might be your medical history and your adverse events. And coming to within groups or within subjects, so group ID values, further it is going to group the records with within your unique subject ID. So all records in the same domain within the same group ID value are a group of records within your unique subject ID. Unlike your category and subcategory, group ID values are not intended to have any meaning across the subjects, and they are usually assigned during or after your data collection only. So although your IDs are your identifier variables, usually they are not considered to be grouping your variables. They may have meaning across the domains, like your MNKID, which is a grouping identifier used to link a feature initially recorded as a result in one findings domain to assessments of that feature in another findings domain, that is to one to many relationships. So this is how your grouping of variables and categorization based upon the subjects. Maybe it can be for the subjects, across the subjects, and within the subjects. This grouping of your variables is done. And with this I conclude my webinar, and thank you all, and let's meet up in the next webinar with further more useful information. Thank you very much.